Looks good.
Okay, great, thanks. All right, thanks for those that just joined. For this presentation, let me just kind of give you a summary as to why I created this presentation. It was about 10 months ago, I joined a small startup company that was essentially a banking as a service. And upon joining the company, it was the most innovative company I think I've ever joined in my career, where we didn't own anything. Everything was infrastructure as a service, platform as a service, software as a service. The only things that we did own was a mobile app. We even paid for a little bit of Azure, and also we had MuleSoft for our API and also our orchestrator, and everything on the back end was essentially software as a service. And so this really created a really challenging situation that I've never experienced such third-party risk in my life, because I was just so vulnerable to what everybody else was doing. And so I started to dig deep into this role as their cyber chief, and I started to realize that the only real control I had was the mobile app and also the APIs for MuleSoft. And so MuleSoft was our platform, but there's lots of other platforms out there. We'll talk about that here shortly. So the reason why APIs are such a big deal right now is that, look, they've been around for a very long time, but they're exploding because of what we could do compared to 10 years ago. 10 years ago, we could not launch a software as a service type of a company, and being able to do this for pennies on the dollar. This would have cost almost millions of dollars 10 years ago to do this, because we didn't have software as a service. And now with all of the software as a service companies, they now have all these APIs. And so if you have car wash as a service for your local area, that's an idea that you can create a mobile app to. You have APIs that can connect to all these local companies, and this could be a platform based on geography. And so there's just so many as a service type of companies out there that this is why APIs are just exploding in popularity, because we're able to do things for a lot less. And at the same time, I make a comment about being able to launch an enterprise scale type of organization essentially in your bedroom, which is pretty incredible. And the reason being is that because now we're paying a monthly subscription fee, and that can be going into Azure or AWS. The top vendors in the space for us, it was the MuleSoft AnyConnect. It's the Cadillac platform. It's the most expensive. It's very complicated. It takes a lot to feed and administer, and also the skill set's pretty tough to get for that. And I would say probably the second most popular platform is the Google Apigee API management platform. That's definitely easier. It's more cost friendly. And then there's, obviously AWS and Microsoft has their own flavors of it. And the Dell Boomi is pretty popular as well for companies that have a lot of legacy backend systems. And so, uh, as far as when it comes to testing APIs, I just wanted to make a call out, and I'm sure a number of you have heard of this. Postman is a super popular tool for testing out your APIs, which I'm sure you're already familiar with, and Jenkins is also another very popular tool for the software development process when it comes to this space. So the reason why I wanted to talk about this today is that from a cybersecurity perspective, we're playing a game of whack-a-mole, and we have all these vulnerabilities popping up everywhere. It's having to harden our servers and our firewalls to our infrastructure. There's all this stuff that we have to secure, but one of the things that we haven't been focusing with is the APIs. And so you would be pretty shocked if you know much about the APIs being used in your company, of how that they're going to become this new attack vector. And we're starting to see some chinks in the armor on this here. And so one of the things that most notably was back in 2020 was Starbucks. And there was a situation that it was an external API, but it proxy back into the organization, and the person who's testing this was able to look at the file path and trace it back to the back-end system, and they had prevented 100 million customer accounts from being exposed. And so this was a close call for Starbucks, but this is the thing that we're starting to see is APIs are starting to get attacked more frequently, and so it's a very different mindset of looking at APIs, because we're so used to looking at traditional cybersecurity controls that APIs are now this whole new category of things that have to be looked at because there's so much complexity to an API. And the reason why is because the software as a service is just igniting this business. And so that's why our conventional layers of cybersecurity aren't capable of protecting against API attacks. So when we look at why we're not able to see what's going on with APIs, is because APIs look like legitimate traffic, and so in most cases it's regular HTTPS type of traffic that's going through your firewall. Sure, the firewall can do stateful packet inspection and look at the traffic, but it really can't stop a lot of the things that's actually moving through that API, and that's where we have a number of issues ranging from authentication issues to also data leakage as well. And so this is how a lot of APIs are able to bypass a lot of our traditional cybersecurity controls that we're using today in enterprises. So one of the most important things for you to consider is being able to know where your APIs are. And so it doesn't matter if you're a big company or a small company, your company probably has a lot of APIs already being used. And so there's always going to be the known ones and unknown ones. And so it's definitely going to take some exploratory efforts to being able to get a handle on the APIs, because there's just so many different types of APIs used out there. And when you do find the APIs, it's really important to make sure that you're always having that inventory of the API, but also validating what these APIs really do, because APIs are evolving and changing. They're very dynamic, and so it may have been meant for this one particular function, but that functionality starts to expand over time. And so when you start to look at this, you need to start having a catalog of how has this API been hardened, and so this way you have a good perspective of what security measures have been put into place. The other thing too is being able to watch out for what I call shadow APIs. One of the things that I discovered in my job is I started to attend daily stand-up meetings with the development team, and I was learning more and more about how there's a lot of APIs being pushed out, sometimes on a daily basis, and they were just coming out too quickly. And then you start to hear, well, that doesn't sound right. And so this is when I started to dig deeper, and that's when I started to get additional training. I started attending the MuleSoft API training classes, because there's so much to know, and there's a lot of things that you have to really start to peel back the layers with an API, and I'll be doing that here shortly. Now, as you know, just a quick history of APIs. RPCs, as you know, is the oldest and simplest APIs. SOAP is pretty much, being phased out. That's an API standard that hopefully your company is definitely getting away from. And as you know, REST API is the most popular one that gets used from Netflix to Facebook, and has certain attributes that it must follow. And also it's just the incredible flexibility and formats that are available for it. Now, I wanted to highlight just kind of the 5 different, actually 6 categories of where APIs fall into. And so this is kind of looking at from a broader perspective that one API is not the same as the other, and so this is how you kind of put them in the white buckets. So when you do your inventory, so from experience API. This is really about something that might be for the let's say it's a web application that they might be accessing, or that it might be a mobile app, and that mobile app is Wells Fargo on your mobile device, and so you're going to have experience APIs on your mobile app there. Process APIs is being able to take data from multiple sources and being able to combining that data. And then system APIs is really actually going to the back end and retrieving that data. So you can see that there's like these three different layers of APIs that how they all work together. So there's not just one API that just goes all the way to the back. There's different APIs that they all have to work in conjunction, and so this is the orchestration portion of it. So this is why more and more organizations are using some type of API orchestration engine for all these things to how you get to this front end to the very back end of systems. And so the other is we have external APIs, which is self-explanatory, and this is something that you might expose to for other developers if you want to be sharing a data source, and then also internal APIs, and that's typically something that you might have a microservice and maybe a back-end legacy application, and being able to pull that data out of that system, and then also APIs with your business partners as well, which is self-explanatory for data sharing. Now, one thing I do want to talk about real quick, and that is there's no such thing as an internal API where you don't have to worry about it. And the reason why I wanted to highlight this here is that you should treat your internal network as if it were the internet. And I brought up that Starbucks case for a reason, because of that situation about the 100 million customers that almost got exposed. It didn't happen, but fortunately, that didn't occur, because I think every one of us on this call would have been a part of that we had an external API that proxied to an internal API, and they didn't have the proper measures in place on that, so they weren't doing the right validation, and that's how they're able to get to the backend APIs. And so that's why I highlight this here, is that you have to treat your internal APIs as if they were external APIs, that we don't lower the security bar just because we think it's on the inside. It doesn't mean that we should lower the bar on this here. That's the whole point of this slide. Now, I want to go over some key principles for you to think about, and that is, the authentication process is just absolutely paramount. And you're having to think about traditional type of attacks, like I mentioned, the man in the middle. Being able to make sure that you're truly authenticating, let's say, your mobile app through the authentication server, and not a software service that might look like the authentication server. And so that's why that kind of leads into the next one here, and that's being able to make sure that you're not doing what surprisingly a lot of companies do. And a lot of companies will actually hard code the client ID and the client secret into the mobile app to authenticate. And so what this means is that we did some static source code scans, and we started to see some very long passwords, and we're trying to figure out the how and why. And by doing it this way, it might speed up the development process of being able to roll out an API, but it's obviously a horrible practice. And so that's why I want to talk about using the OAuth 2.0. And this is the framework that you actually do authenticate against an authentication server by checking each incoming call for an access token, which must validate with a tokenization server. And so with this here, you want to make sure that you don't have any tokens that are being replayed or expired. And your development team will probably push back on this here because it does take a greater development effort, but it's so paramount because you don't want to find yourself in a situation where you have developers trying to hard code client secrets in the mobile app. So one of the other key things to mention is, when we think about when we do have an orchestration engine for APIs, is thinking about the SAML integration that might, you know, uh, because we want to make authentication as seamless as possible, that we're not having to make multiple stops for authentication, and so this is being able to use SAML for whether it might be Active Directory or ping identity, federated identity. So it's really important to try to create that seamless experience from the front end to the back end, because if you're doing a lot of mobile app development, whether it's an e-commerce store or a bank as a service, you have all these back-end software as a services, and obviously trying to bring all of those into a unified authentication experience is really critical, and having to authenticate to each one of them for obvious reasons. The other thing to watch out for is you would be surprised how many APIs get used for like a mobile app or a web app. It's what I discovered is that there are just so many APIs that are being developed on a weekly basis and being slammed in that I was pretty taken back by the number of APIs, and it's just so important to make sure that you're validating each one of these APIs. And the other thing is also being sure that you definitely sign your level code as well, which is a really important process. Um, Another thing is that, how do you deal with how can I trust the API I have? How do we know that somebody didn't take the mobile app, decompile it, and tamper with the API? And so you can do some type of signature with the API, and this is more of a cybersecurity technique here, and that's being able to um, essentially you can do some type of algorithm or a secret code, and by performing this check, this is being able to validate that the inbound connection is being matched against a list, and so this way you can trust that API, that hasn't been tampered with. So it's a suggestion, but it's a way to enhance the security by being able to put some kind of an ID or a marker on your APIs, especially your authentication API, which is a really important one. Let's see. The other obvious thing is there's still a lot of older web apps. This is, I see this more on the web application server side, still using HTTP for API transmissions, and that's obviously easy pickings. And that if you are going to do it, please use at least TLS 1.2 for your authentication or your transmission of your API. Now, the other thing I wanted to bring up is the use of load balancers and the API gateway. And so, as we know that the load balancer can go ahead and take a call on the front end and be able to propagate it and get it to the hosting server, which might be on the back end. But the important thing to think about is that when you're doing that, leveraging some type of a message broker queue, because let's say you did have some type of failure, that if that service did fail, that you would be able to at least queue that message, and then when the service comes back online, let's say it went down for 5 seconds or 10 seconds, that it could go ahead and try to rerun again. And so you have to think about business continuity perspective for your APIs and how you keep the message integrity with that. And let's see, the other thing too that I wanted to highlight, that I'm surprised that hasn't happened yet, or at least I haven't heard of it, and that is for a lot of these mobile apps that do get created, I started to discover that the authentication API is probably the most vulnerable API, because if someone wanted to do some type of a denial of service attack, this would prevent the app from authenticating the user. So if you're able to do that, that means that the mobile app, you're not going to be able to launch that correctly. And so this is where a load balancer with proper controls can be put into place to make sure that that doesn't happen. Because, as I mentioned previously, if you do have somebody that is actually hard coding the client ID and the client secret in the mobile app and it got decompiled, when you make the, if you're going to do a DOS attack, you're going to be able to look like legitimate traffic, and the load balancer isn't going to be able to really tell that you're malicious traffic because you look like legitimate traffic. So, something to think about from a development perspective. Let's see. The other thing I wanted to highlight is there's a lot of, I mentioned about the 3 different types of primary APIs. I talked about the experience, the process, and system APIs. One thing that I strongly recommend is using a different client secret for each API. However, you might be getting some pushback from development, and if you do, a good compromise would be to focus on those 3 key areas where you have maybe the same client secret for system APIs, the same client secret for experience APIs, and so this way we're not using the same client secret for all of your APIs, because if you have one API that was exposed, that means they're all going to be exposed, and so something to think about from a development perspective. And if you're going to do that, think about key rotation as well, that you're going to be changing out your client keys as well, so you need to think about that as well from a planning perspective. Now, as far as some of the tools that you might find available in some of the, like MuleSoft or the Apogee platform, and that's being able to use some of the built-in capabilities to enhance the cybersecurity aspects of it. So, for instance, being able to make sure that a client ID that you're expecting matches the client ID that you're expecting on the receiving side, let's say MuleSoft, for instance. Also, rate limiting is so important, because you don't want to find yourself in a situation where you're getting too many calls coming in, because you could go ahead and overwhelm the API listener, and this way that you need to appropriately balance, what's going to be a very busy API that's going to get hit all the time versus one that's probably going to get checked on maybe every minute or so. So this is a balance, so you have to rate limit each one of your APIs and have kind of a strategy behind that. And also, SLA throttling, same concept of rate limiting, except that if you are exceeding your thresholds, that it just waits for the next time limit. So this is something to think about, that you go through some kind of a peak period. Also using the OAuth 2.0 access token enforcement. So this way, this kind of makes it a nice experience, that if you have this token, that you could be validating the person if they're going to different parts of your website, for instance, and then also LDAP, and making sure that you use the LDAP version. And then, as far as there's a few more things here I want to highlight, being able to blacklist and whitelist. This can be kind of tricky. It's somewhat effective. Sometimes, if you want to blacklist something, that someone who's trying to maliciously attack you is just going to switch the IP. So I think it's really just kind of a short-term thing that helps out. And then also being able to use the JSON XML threat protection capabilities to protect the message itself, and also spike control, because you might have a situation where maybe it's payday, and this is happening every 2 weeks. So, how long are you going to allow this spike versus if it was some type of a denial of service? So it's important to understand what's legit and what's malicious. And then the other aspect is with APIs, if you want to go ahead and strip away the header injections or to remove them, so this way you're not divulging information about the resource, the server name, scripting, versions, access control, etc. And then finalizing this here, tokenization. Surprisingly, this is meant a little bit differently, and that's being able to actually to protect the payload that's within the API. So let's say that some of the API layers were taken down. Let's say the authentication wasn't done correctly. That if somebody was trying to listen in with Wireshark, that you still have a way to still protect the payload. And so this is something that's fairly new to APIs. And then also just being able to have some type of JSON web token validation policy, and that's being able to validate the signature of the token and asserts the values of the claims. And so once the user is provided credentials, that they don't have to keep providing the same credentials over and over again. And that's from a performance perspective, because you don't want to have to keep querying the same authentication server over and over again. And then there's what's called edge security policies, and this is really kind of think about either on a browser or on a mobile app. And so for this here, this is being able to, the first one's really obvious, from a DOS perspective, being able to whitelist that. Let's say you want to limit the countries that you have people accessing this from, and then also being able to prevent large messages from trying to be sent to overwhelm the processing bandwidth for the API as well. And then for the WAF aspect, this is being able to leverage some of the existing OWASP core set for checking the requests and responses to detect some of the basic web attacks. It's okay, but it's not going to be a game changer. It's just an additional layer of control. Another important thing is to monitor your APIs. And so what I mean by that is, one, you have to understand every API is going to work differently. So you're going to have some APIs that you're going to have to understand from a baseline perspective. Some are going to be very busy, some are going to be very lightly used. And so you want to be monitoring for the bottlenecks, if there's any security settings that might not be working correctly, or if it's dropping high amounts of malicious traffic, making sure that the rate limiting policies are working correctly. So this way you're not in a situation that you're actually dropping legitimate traffic, because that's when, if that did happen, that makes cybersecurity look bad. And so it's really important to stay proactive with the monitoring perspective for your APIs, and also just being able to set thresholds and alerts whenever certain events what doesn't look normal. One of the things I want to highlight real quick, just to give you an experience, if you think about a use case, this one here is like a customer loyalty experience. I just kind of want to talk about what do these APIs actually look like. And so for the experience APIs, and this is whether it be a mobile app or a web application like on the browser, it might be a point of sale API, a my shopping API, self-registration API, a shop assistant API. And then if you think about the process APIs, that's being able to combine the data from sources and moving that data to the right systems. Excuse me. And that is, for instance, like a registration API, order fulfillment, or a sales API. And then lastly, the system APIs you can think of as pulling data from the database, and that's the customer API, notifications, orders, user payment, catalog, and recommendations API. So I wanted to put some context as to how the APIs are being used within your environment. And then I just wanted to highlight, what does the future of API security look like? And this here is a screenshot from MuleSoft. This function isn't available yet, but it's being able to add a layer of being able to almost like add some DLP protection within an API. And so this is something that's going to be forthcoming, and so this is something to think about as well. That's another control to think about that you can leverage. And the reason why that's really beneficial is if you have an authentication API, you shouldn't be seeing a social security number or a birth date in that API. And so this is something to make sure that your APIs are working correctly. And then I wanted to provide some sources here. As you know, we have the OWASP API Security Top 10, which is an excellent resource. Some of the companies in this space you might want to take a look at. I'm not endorsing these companies, but they're pretty popular, and it's something to think about if you want to kind of take your API strategy to the next level. I mentioned a few of these companies here. And then lastly, this was just some of my references for my presentation here. So that's my presentation. I just wanted to open it up to see if anybody had any questions.
All right, thank you, Todd. It looks like, oh, you had some feedback from the audience.
All right, sorry if I was a little low on the sound.
Sunshine?
John's trying to talk to me at the same time, hold on.
Last speaker in the track.
Alrighty, Todd, I don't have any questions for you on the chat or in Discord, so thank you very much for your presentation.
All right, thank you.
And we'll say goodbye. Thank you.
Adios.
For anyone interested in Todd's presentation, those will be up